Hello guys, welcome to my YouTube channel Basic Electrical Engineering. So from this video we are going to start the basic electrical engineering. Okay, we'll go through we'll clear the concept of basic electrical engineering and we'll go through this all these contents. As you can see here, basic concept, DC circuit, DC network, units, electronics, capacitor, magnetism, magnetic circuit, electromagnetic induction, AC fundamental, chemical effects, series AC circuits, phasor algebra, parallel AC circuits, polyphase, instrument and measurement, AC network analysis. So we are going to make small videos, okay, small videos on this chapter, on these topics. Within basic concepts we will make 3 4 or 5 6 video, okay, 5 video, 5 or 6 videos, 5 6 video, like that. We'll make small videos for all the topics, all these topics, so that you'll not get bored. And yeah, these videos will help for the BTech and for BTech, BE, also for MTech it will be helpful, and especially for in any kind of engineering job, okay, engineering exam, any kind of engineering exam or interview or anything, you must need to clear the basic of electrical engineering. If you are from electrical engineering, if you are doing BTech in electrical engineering, okay. We'll make the playlist from today. With this video we are going to start this basic electrical engineering. So let's start today the basic concept, okay. So nature of electricity, okay, nature of electricity. Suppose we know all the particles, any particle any particles have electron and proton. What they have? First they have proton and electron. We know any particle has electron and proton. Electron and proton. Suppose this one is one particle, okay. Inside it we know the proton P, electron E, we are denoting proton with P, electron with E. Proton stays in the center, okay, and electron stays the orbits, outer orbits, okay. Each orbits has electron. So this particle is electrically charged or not, it depends on the number of this proton and electron. So at first case, if the number of proton at the center, okay, number of proton and the number of electron on the outer parts, if is equal, okay, number of proton is equal to the number of electron, then the particle, then this particle is not positively charged or negatively charged. And second condition, when the number of proton is greater than the number of electron. When the number of proton is greater than the electron, proton is, we know proton is always positive and electron is always negative, okay. So when the number of proton is greater than electron, so the particle, this particle is positively charged. Okay, positively charged this particle. When number of proton is less than the number of electron, or you can say when the number of electron is more than the number of proton, that time the particle is negatively charged. Okay, so unit of charge, SI unit of charge is coulomb. Okay, we know that SI unit of charge is coulomb. So what is a coulomb? 1 coulomb charge is equal to the charge on 625 into 10 to the power 6 electron. Okay, 1 coulomb, SI unit of charge is coulomb. But what is coulomb? Coulomb is 1 coulomb charge is equal to the charge on 625 into 10 to the power 6 electron. Okay, so the charge on, so the charge of electron, so the charge of electron is 1 by 625 into 10 to the power 16. We are using one minus symbol here because we know electron is negatively charged. Okay, so it comes as minus 1.6 into 10 to the power minus 19 coulomb, minus 19 coulomb. Now the electron, the mass of an electron, m is, we got here the charge of electron minus 1.6 into 10 to the power minus 19 coulomb. The mass of electron is m, it's denoted by m, it's 9 into 10 to the power minus 31 kg. Okay, SI unit, all are SI unit. And radius of an electron is denoted by r, is 1.9 into 10 to the power minus 15 meter. Okay, so E by m ratio comes as 1.77 into 10 to the power 11 coulomb per kg. So let's discuss about the valence electron. So what is valence electron? Valence electron is the, suppose this one particle is here. Okay, proton inside, proton outer part, electron outer part, electron. The electrons in the outermost orbit, these are the orbit. Okay, this 1 2 3, this particle has 3 orbit, 1 2 3. Okay, I have given only one electron in one orbit, it can be more than 1 or 2 or anything. Okay, so what is valence electron? The electrons in the outermost orbit of an atom. So what is valence electron? The electrons in the outermost orbit of an atom. Okay, so this particle, this atom, what is the valence electron number of valence electron here? This is the outermost, 1, 2 and 3. For this particle, how many? 3. So on the basis of electrical conductivity, materials are generally classified into conductors, insulators and semiconductor. Okay, depending upon the number of valence electron, one particle is classified that it's a conductor, it's a metal, non-metal, or a gas or solid. Okay, on the basis of electrical conductivity, materials are generally classified into conductors, insulators and semiconductors. So first condition is when the number of valence electron, when the number of valence electron when the number of valence electrons of an atom, this is one atom, is less than 4. Okay, less than 4, then the material is usually a metal and a conductor. Then the material is usually a metal and conductor. Okay, so it will pass the electricity, metal or conductor, when the number of valence electron is less than 4. When the number of valence electron is more than 4, then sorry, it's non-metal. Okay, non-metal and non-metal and insulator. Conductor, metal, conductor is good for flow of electricity. Okay, electricity can goes through a conductor, any type of wire that use in electricity board or anything, gold. sodium, magnesium, aluminum. Then third condition is when the number of valence electrons is equal to 4. Okay, equal to 4. Or let me clear one thing. This the outermost orbit, it can contain maximum number of 8 electron. Okay, maximum 8 electron. The outermost part of an atom can contain maximum of 8 electron. So now when the number of electron is equal to 4, so the metal will be that particle will be both metal properties plus non-metal properties. So that particle will have both the metal and non-metal properties. This type of properties, it's called when some particle has this both the properties, it's a semiconductor. Okay, examples are carbon, silicon, germanium, so for this lecture, we're going to end it here. Okay, in next video we'll continue the basic concept part. Thank you guys.